Yes.
And we are being live streamed.
Oh, I'm getting the countdown. Live from Yarker. Okay. Welcome, everybody.
It's Wednesday night.
It's Wednesday night, 7 p.m. Welcome to the Kingston Center RASC regular meeting. I'm glad to have everybody here. And I would like to welcome all of our guests here locally as well as on YouTube. And we have two new Kingston members. We have Siobhan Baker and Brian Mccracken. Brian and I have been chatting by email, and he's an astrophotographer. So I'm sort of hoping that he does show up tonight because he did have a lot of questions.
Yes,
Okay.
Kim, I am here.
Awesome.
I'm an aspiring astrophotographer. I'm hoping.
That's okay. You've got a camera. You're an astrophotographer. Okay. So I was just waiting to see whether Bruce Elliott has shown up yet. Bruce is here and he wants to give a little announcement about the science fair. And then we will go into David Levy's poetry introduction. And we'll have our guest speaker. Then we'll have John Hurley, our National Council rep, Hank Bartlett with Hank Sunspot, Rick Wagner with what's up in the, that should be the March sky, and Science Rendezvous notes, and then what's happening next month. So right now, Bruce, do you want to go ahead and let us know what's going on?
Thank you, Kim. I appreciate that. So the Science Fair 2022 is, again, this year going to be completely virtually online. And everything seems to be progressing well with it. But the key goal now is this time is recruiting judges for the from our center for the Astronomy Award that we give, the Leo Enright Award. So I'd like to say that last year we had Graham Hay and Elena and myself. And Graham has generously agreed to join us again this year. It would be great to have one more volunteer to help. Preferably female, if you don't mind me saying, because it would sort of balance out the the last year there were we had, I think, 7 maybe it was at least 7 astronomy related projects, and I would say about 2/3, at least 2/3 of them were young women that were students, and it was really great to see that participation. It's all, as I say, it's all virtual this year, and I'm the only one, though, of the judges that would really need to register. And once that happens, I can transfer the information appropriately to the people. So it's really not a huge amount of work. The project links will be available on March the 28th. We'll get about 10 days before that, we'll get a list, an Excel sheet just giving the title and a brief summary. And then, as I say, we pick out from that, and then we get to look at the projects online. They usually have. Last year, it was really nicely set up, and each participant had a chance to give a 3 or 4 minute video, sort of live video, not live, but a real person talking on the other end, and that was really very good, very well done. Anyway, I can share all this information with people at the appropriate time. But if there is anyone else that would like to join Graham and myself, that'd be very much appreciated. And of course, we need to come to a final decision for who the awardee will be on April the 5th. So we get the projects to look at on March 28th, and we have about a week to fix it up. So I think that's all I really need to say about it tonight. Thanks, Kim. And hope everybody enjoys the rest of the evening. I unfortunately will have to leave a little bit early.
Okay, thank you, Bruce, for that great update. And hopefully everybody will consider about possibly helping out and being a judge. It is a great inspiration to see these kids come through and see their science projects.
Mm-hmm.
So next, we're going to have David Levy, who's going to give us a poetry introduction. David?
Thank you. Thank you so much. And whenever I come to these meetings, it reminds me of the very happy years I spent at Queen's getting my master's degree. And today my quotation comes from the Iliad. And it's interesting when I'm looking up comets from the Iliad, depends on the translation, because the one I'm going to quote you come from Alexander Pope's translation. I'm trying very hard to find it in George Chapman's translation. I think we all know that from the Jonathan Keats famous sonnet, then felt I like some watcher of the skies. But this is from Pope's translation. A peaceful guest of the Iliad, a peaceful guest. He sought Mycenae's towers. Armies he asked, and armies had been given. Naught we denied, but Jove forbade from heaven, while dreadful comets, glaring from afar, forewarned the horrors of the Theban war. I think with everything going on right now, this is as appropriate as I could find a quotation for tonight. Thank you so much, Kim.
Thank you, David. That is excellent. So I'm going to introduce our next our guest speaker, Marcus Leech. Marcus is the president of the Canadian Centre for Experimental Radio Astronomy. He also worked with a group of volunteers at their oldest project, which is the Shirley's Bay facility, which apparently doesn't exist anymore. But he gave us the talk on that on May 2008. Marcus has over 30 years experience in the technology development industry in both software and hardware. He is very active in the Society of the Amateur Radio Astronomers, the Ccera group, and makes presentations to the BAA, the British Astronomical Association, and is also a licensed radio operator, VE3MDL. Currently, the CCERA is using a GNU software, radio software, which is a Unix-like operation system, and it runs it on the observatory equipment. So further ado, I'd like to pass this over to Marcus.
Thanks very much for the introduction, Kim. I'll just share my screen here. And hopefully get onto the slideshow. Okay, can everybody see that?
Okay, yes, we're good.
Okay, so I'm going to be talking about our FRB project, hunting FRBs on a budget. We've chosen to call this the Fft telescope, and sifting is it's an apropos term for what it is you are trying to do when you're looking for fast radio bursts. So I'm going to give a very quick overview of CCERA because many of you probably haven't heard of us. And the last time I spoke to this group, we were running a different project at Shirley's Bay. So we founded ourselves as a federal not-for-profit in 2016. And we were located at the former Rideau Regional Center just outside of Smiths Falls until February 2021. We had technical and political forces that caused us to move to the new site. We actually spent several months looking. Once we knew we had to move, we spent a fair amount of time looking for a suitable new place. Lots of places were looked at and evaluated. In the end, I took up Rob Dick on his offer of several years ago to host some of our equipment out there. So we're now located on his 38-acre property near Rideau Ferry. So actually a little bit closer to Kingston than our previous Smiths Falls site, although not by a huge amount. So our mission, we engage in small scale research activities. We do a lot of tool development and technique development that supports small scale radio astronomy. And by small scale, I'm talking about things that people might want to do in their backyard on their own, or smaller institutions that have no real opportunity to, basically build a big exotic radio observatory for themselves, community colleges, even high schools, that sort of thing. So we document what we do, and we produce a lot of tools and software. All of that gets published. We collaborate and partner with academic institutions, mostly in support of undergraduate astrophysics programs. We supported Carleton for several years. They had an undergraduate astrophysics program, and we provided observational support to them. Unfortunately, that fell apart when COVID happened, because their undergraduate, the lab portion, as far as I can gather, the lab portion of their astrophysics program got turned off, and we were funded through that part of their program. So we couldn't, we didn't get any funding after that point either, and we ended up having to revector some of the things we were doing, which is fine. I mean, these sort of things happen. So in the spring, summer, and fall of 2021, we started basically rebuilding our capabilities out at Rideau Ferry. But at the same time, we augmented what we could do quite significantly. The land that we're sitting on is owned by Rob, and we have access to all of it, really. And we don't really have a lot of restrictions about what we can do there, other than staying within the law and the bylaws and all that kind of stuff. Whereas at the Rideau Regional Center, also known as the Galapagos Center, we had a lot of restrictions on how we could do what we did, where we could put antennas, how many antennas we could put up, all of that sort of thing. So when it came to pass that we had to move out of there, it wasn't as big a heartache as we were really expecting. That place, of course, had modern-ish facilities, and, bathrooms, and we had real office space and all of that sort of thing. But from a scientific perspective and from a technology perspective, deploying technology, it wasn't nearly as nice as this site in Rideau Ferry, which is just in behind Rob Dick's optical observatory. We're about 60 or 70 meters away from the optical observatory that's on the same site. So we have a 33-foot science trailer that we call it. That was donated by one of our people, Gary Atkins, who is a retired technician from the Canadian Space Agency and has been involved in this effort for several years. He happened to get a trailer for free a couple of years ago and had been working on, making it more or less watertight and all of those things, but didn't really have an immediate use for it. So we hauled it out to the site and made it our science trailer. And you can see the equipment racks we have there, computer screens and all that kind of stuff, and cupboards where we keep all our tools and bits of material and all of that kind of stuff that you need when you're building and operating a site like this. So the main thing we're doing at the site at the moment, sort of our main thrust for the next couple of years, is going to be observing FRBs, or fast radio bursts. So I'm going to talk a little bit about what those are and why they're perhaps interesting. So they're a newly observed phenomenon, but not necessarily new in terms of the cosmos. It's just that as observing techniques have matured and evolved over the years, new things have popped up in the data. And the first time that happened was when Duncan Lorimer and his research assistant, I think it's David Markovic, in 2007, identified the very first fast radio burst. After that happened, it became a thing for observatories to actively go looking for these things in more or less real time, as well as, of course, going over old archival data, mostly from pulsar studies, to look for these radio bursts that would happen once and then never be seen again. But they had properties that indicated that they were very, very likely coming from out there, as opposed to, you know, from Fred's microwave oven or whatever. So the origins aren't that really positively identified yet. There's lots of theories, nothing that's really definitive. So are they the result of black holes merging? Are they from magnetar outbursts? Are they really, really big, giant pulses from existing pulsars? All of those have been put forward. Some of them are supportable by the data, others not. So it's actually an interesting field to be in at the moment, because we don't know exactly what causes these things. Some of them, there's very high probabilities of what it is they are, but others we don't. So it's an exciting new field to be involved in. They're brief. They're typically a few hundred microseconds to perhaps 1 or 2 milliseconds in duration. They're often quite bright. The one that was observed by the STARE-2 project, which I'll talk about in a little bit, had a peak flux of over 1 million Jansky, which is, I mean, that's huge. That's the kind of output power that the sun produces at certain frequencies. They're highly dispersed. So most of the Frbs we've seen to date are assumed to be extragalactic due to their very high apparent dispersion measure. And we'll talk about dispersion in a minute. They're distributed more or less uniformly across the sky, although we haven't observed enough of them as a civilization yet to really definitively say that they're fairly uniformly distributed. There are some statistical exceptions. M81 seems to produce a few more than other parts of the sky. Most of them, like probably 90% or better, are singletons. That means they never repeat. You see it once and you never see it again, at least at timescales that humans have been observing them for. There may be ones that repeat on timescales of years, and we wouldn't have seen those yet. There are a few that repeat on a much shorter timescale, but not so short that they fit into the existing model for pulsars. So there is one famous repeater that repeats on a roughly 16.5 day interval. So we're actually going to be monitoring that one and M81 because they're kind of statistically more likely spots to be getting these bursts from. So I talked a little bit about dispersion. Any electromagnetic wave traveling through the interstellar medium or the intergalactic medium will become dispersed due to traveling through what amounts to a very, 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 very deep plasma column. Shorter wavelengths tend to arrive ahead of the longer wavelengths, and that's just the nature of EM propagation through a thin plasma. And the same thing happens in optical fiber. And in fact, very high-speed optical fiber systems have to account for the dispersion in fiber and deal with it. So the observed dispersion is called a dispersion measure, and that tells us about distances to objects like pulsars and Frbs. There's some uncertainty due to the non-uniformity in the ISM and IgM plasma densities, but like I say, close enough for cosmology work. Pulse-like wave structures, like from pulsars and Frbs, will become smeared due to the dispersion, so smeared in time. So if you're looking at a very wide band of them, they may actually become smeared below the ordinary detector limit. So you need to have detection mechanisms that are aware of dispersion and invert that dispersion prior to detection. So fortunately, the pulsar world developed these techniques decades ago for dealing with dispersion with pulsars. most of the pulsars in the sky, unless you have a very large dish, you can't even see them without applying, well, you can, but the very low signal to noise ratio, without applying some de-dispersion to basically undo the dispersion that was created by its travel through the ISM and the IGM. So in terms of observatories out there in the world that are doing essentially set up just for looking at FRBs, there aren't very many of them. The one that is most famous is the Chime Instrument in BC at Penticton, built in 2015 for observations of redshifted hydrogen, looking for signals from the what's called the epoch of reionization. But it turns out that the facility and the antennas and so on were ideal for building what amounts to an FRB machine for detecting FRBs. So that 4 of these very large parabolic cylinders, they're about 20 meters by 100 meters. They have 256 dual polarization feeds per cylinder. All the signal processing is digital. They cover a receiving bandwidth from 400 megahertz to 800 megahertz. That was chosen largely by the redshifted hydrogen folks, but it turns out to be okay for looking for FRBs as well, because FRBs are very broad band. The problem, though, is that that band is becoming increasingly contaminated with radio frequency interference. So at any given time, some part of that band is not useful for doing detections. Sometimes I think as much as even 30% to 40% of the band is unusable. So in terms of the back end that the FRB system uses, they use something called a 2D Fft Beam Former, which is a fancy signal processing thing that basically allows you to have just a whole whack of, flashlight beams on the sky, all orthogonal to each other, covering basically the entire, more or less the entire visible sky at any given time. It isn't the whole sky, I mean, but it's most of it. So a single cylinder has a field of view that's about 1.5 degrees in the east-west direction and 110 degrees in the north-south direction, arranged as 256 beams, which of course comes from all of these feeds on the antennas. Recently, they've built an outrigger cylinder near Allenby, BC, which is near Princeton. It's about 100 kilometers away from the main observatory. Excuse me. And they detect a few FRBs per day, give or take. Construction cost about $16 million for the main instrument. I don't know how much they spent when they decided to use it for FRBs as well, because I think they added an entire trailer load of equipment when that decision was made, and I don't know how much that cost. I imagine, I'm going to guess a couple of million extra. The other observatory system that was set up specifically to look for FRBs is a project called STARE-2. It's the follow-on to a project I was actually involved in very peripherally a few years back called STARE-1. The idea is to have several geographically separated telescopes with a very wide beam, so you get a very large field of view, and then you use time of arrival to localize the source of any emissions. So STARE-2 is centered at 1420 megahertz. STARE-1 was centered around 400 megahertz. It has about 180 megahertz of instantaneous bandwidth. And I typoed there, I misspelled source. Anyway, you all get it. The single beam has a field of view of about about 100 degrees. And that's because their antenna really is just a regular microwave feed horn for 21 centimeters. And they generally have a beam width of around 90 to 100 degrees. And the whole thing kind of sits at the vertex of a big dish antenna that they're using as nothing more than a ground screen. They just happen to have these lying around and they're using them as a ground screen. So there's nothing particularly special about the dish that they sit inside, except that it lowers the ambient noise that is being seen by the feed. So they started that about 3 years ago now, and so far they've had one successful observation from a magnetar called SGR 1935 plus 2154. The dispersion of that indicates that it's right on the edge of our galaxy. So unlike other types of FRBs that are mostly extragalactic, this one is actually just inside our galaxy. They have a digital RF processing toolchain using Casper hardware and software. The Casper project is run out of the University of Berkeley. They have basically a radio astronomy instrumentation lab there, and they've developed a lot of hardware and software over the years for professional observatories. So the main site for STARE 2 is at Owens Valley, which is a radio observatory run by Caltech. I don't know where the other two sites are, but they are at least several hundred kilometers away, so that there's enough time of arrival difference to be able to measure. And then, of course, there's us. Now, there may be a couple of more in the world, but most of the FRB observations at the larger observatories are a secondary concern, and it's just an observation of opportunity type of thing. So there's very few observatories in the world that are explicitly dedicated to observing FRBs. And you could argue that Chime isn't either, except that because it has dual processing chains and the antennas are fixed, that it's exactly like a dedicated instrument. So we have our own setup that we're calling the Simple Inexpensive FRB Telescope, or SIFT. Currently, it's 4 modest size antennas, dish antennas. 3 of them are 3 meters and 1 of them is 2.4 meters, centered at 21 centimeters, mostly because we already had lots of equipment for that, and it's a quiet band. There's 27 megahertz of bandwidth available in there that is essentially reserved for radio astronomy. Our observing bandwidth, just due to equipment limitations, is 15 megahertz of bandwidth. We use GNU radio-based signal processing chains. So it's digital signal processing, but most of it, instead of being done on dedicated signal processing hardware, is done in software on more or less ordinary computers. We're currently using USRP receivers just because we happen to have a number of them lying around, but many others could be used too, and I list a few of them there.
Okay, Marcus, Kevin here. Just while you're taking a drink, your Thunderbird has popped up a window on the screen here.
Oh yes, I'll just make that go away.
Just hopefully that there's nothing really embarrassing coming in.
I don't think so. That would be very exciting, I think. So yeah, we're going to add 1 or 2 dishes this summer, hopefully, and we have secured access to a 14-meter ex-NATO antenna in CARP for doing multi-site validation. We're still kind of fluid on exactly how we're going to take advantage of that access. One of the observing plans involves a potential black hole merger that's going to happen in the next 2 years. And being able to basically dedicate time every day to observing that source to sort of capture the moment of the black holes merging is interesting, but we can also use it potentially for doing validation of other observations, and potentially even set up other small antennas on the site. So that's actually our security cam picture of our antenna field as of a few weeks back. That was one of the last images captured before the camera failed. I have a replacement camera sitting in my living room waiting to go out to the site. And as you can see, it's a little bit like Arctic tundra out there, so it's not really easy to get to during the winter. You can't just drive right up to the site like you can in the summer. So we haven't visited there a lot. I just do a lot of remote stuff and had been using the security cam to look at the outside, but that hasn't worked in a few weeks. We were actually back there a few days ago to confirm why the security camera failed and do a couple of other things. We should be able to have external cam footage again very soon. So I want to do some sensitivity comparisons between what CCERA can do and what these other two observatories can do. Because I mean, the obvious question is, well, you know, given your very tiny budget, what can you actually achieve? So if you look at the sensitivity comparison based on the aperture differences between what we have and what Chime has, for example, Chime's effective aperture is about 36 times greater than ours. And Stare 2 is, we're about 400 times better than the Stare 2 aperture. However, when you're dealing with radio astronomy sensitivity, you have to factor in a bunch of other things as well. We're going to ignore things like the noise temperatures of our low noise amplifiers because they're actually in the same ballpark as the other two. The other main thing is the bandwidth. So because of basic statistics, the greater the bandwidth over which you observe, the more sensitivity you have. So if you look at Chime versus CCERA, they are, based on their bandwidth, about 7 times more sensitive than we are. And Stare 2 is about 3 times more sensitive than we are, just based on the bandwidth. Now, if you aggregate all those numbers together to come up with like an aggregate sensitivity number, the SIFT reception chain is still about 100 times more sensitive to events than Stare 2. It's obviously never going to compete with Chime, but we are more sensitive. So the other thing, sorry about the coughing. The other thing that we need to consider is the field of view. So Chime covers an area of about 165 square degrees on the sky at any given moment. Stare 2 covers about 12,000 square degrees at any given moment. So they have way more instantaneous sky coverage, but their sensitivity is very poor. They can only really see very, very bright events. Ours, of course, is somewhere in the middle. We have, with the 4 antennas, about 100 degrees squared at any given moment, and we'll be adding another 50 degrees squared this summer. So we estimate that given all of this, we should be able to detect a handful of events every year. Chime detects 1 or 2 verified events a day. We're going to be sort of ballpark the same thing per year, but that's just fine. Everything you detect is adding to scientific knowledge and is a feather in our cap. So in terms of the signal processing chain, I'm not going to go into super detail because digital signal processing is kind of an abstruse discipline. But what we do is we use something called a stuttered observing approach. So we observe the sky for 10 to 20 minutes and we produce something called a filter bank file. And filter bank files are very common in pulsar signal processing. And the filter bank output sample rate is about 12.5 kilohertz. So that gives us 80 microsecond time resolution. Then we take the filter bank file and we analyze it at various delays. Remember, I had spoken about dispersion causing delay. So you don't know in advance whether what the dispersion measure is of any possible events you have in your data. So you iterate over several different estimates to see if any of those delay estimates produce a pulse that exceeds your threshold setting or your sigma above the background noise. We analyze in 2-second windows. So the analyzer grabs 2 seconds worth of data from the filter bank, applies the analysis algorithms, and then produces an output if there are any pulses in that window that exceed the threshold. Once that data set is produced, we apply some heuristics we make sure the peak result is at a meaningful DM. And what I mean by meaningful DM is that very low DMs are likely not FRBs. They're much more likely to be local due to some what they call swept RF source, or possibly from a solar radio burst. So if it makes it through all the heuristics that basically eliminate garbage data or data that's not interesting to us, then we save it. And then I look at it manually as time permits to see if this is anything really interesting that we want to look into any further. And that process just repeats forever. So 20 minutes at a time, gather that data, analyze it. It takes like 2 to 3 minutes to analyze it. And then we're back to recording data from the sky again. So we don't have continuous processing of sky data like Chime does. And that's just because we don't have enough computing budget to do that. And the reason for that is that we don't have enough power going into our science trailer to keep all the necessary computers going. So we had to kind of make do. So we use 2 different GNU radio flow graphs to do the main bits and pieces of this processing. The receiving the live radio bandwidth to produce the filter bank, that's one flow graph. That's the thing that runs for 10 to 20 minutes and produces the filter bank file. And then there's another flow graph that applies the delay estimate and look for pulses. So those are both done in GNU radio, but in completely separate flows that run one after another. So results. I want to preface this by saying we don't have any results that we would confidently say are actually FRBs. But we do, every few days, get something that passes through all of the various gauntlets that I need to take a look at. This is one from 3 days ago that I just kind of picked at random. It happened at 025643 LMST, and the observing declination is +5. The antenna that this is on has been sitting at +5 for weeks. So this is what an event would look like. Now, looking at it, it's got, it's about the right width. It's like, a few milliseconds wide at the half power point. The things that tell me this probably isn't is that there's this subpulse here, which would be unusual as far as I can tell. And there's this little thing right here, which tells me it's probably something else, probably not a solar burst. And we go to the analysis. But if we look at in terms of the delay, the dispersion measure or the delay slope, where this thing had a peak signal to noise ratio, it's at about 5.5, which is just a number that's used in our delay processing. That implies that it has a dispersion measure of about 165, which puts it, fairly far away, but still well within the galaxy. This graph, delay slope versus SNR, only suggests a very weak FRB origin for this signal. But it is kind of typical of what you'd expect to see for a real FRB. There will be a peak in signal to noise ratio at some delay slope other than 0 and hopefully high enough that the things we know about the physics mean that it's, you know, fairly far away. So it happened roughly 2 hours prior to sunset. So maybe a solar radio burst, but the apparent dispersion suggests otherwise. L-band solar radio bursts will not have much dispersion at all. You know, at any bandwidth you look at, they're all going to be occurring, particularly at L-band, will be all occurring at more or less the same time. Could also be, and I suspect this is the actual explanation, what they call a microwave oven periton. When you turn off a microwave oven, if you open the door as the way you turn it off, it actually takes a small fraction of a second for the magnetron to spin down. And while it's doing that, it produces a burst of microwave radiation that sweeps in frequency from roughly 2.5 gigahertz or so to much, much lower frequencies as the energy going into the magnetron collapses. There are a couple of houses within about 300 meters of our antenna site. So it's possible that that's what we were seeing there. Now, Chime uses machine learning to help throw out all of these unlikely candidates. And we may adopt a similar strategy as the third processing step, because having me in the loop every time is going to get, you know, tiring and boring pretty quickly. So we'd much rather have something automated to do that. We receive events at a rate of, you know, a couple per, maybe 2 events every few days per dish, something like that. It partially depends on where we set our detection thresholds, but at the moment it's, you know, a couple of events every few days. This is a much higher rate than you'd expect for Frbs, given our sensitivity and the amount of sky we're looking at. So the question then becomes, how do you separate the wheat from the chaff? And we don't have any good answers right now, one of which is to establish a secondary site that has matched pointings. So what we can do with that, even if we aren't doing time of arrival analysis, we can look at the event times, you know, on sort of millisecond time scales and say, oh, look, the other site saw the same event. And if the other site is far enough away, which at L-band would be, you know, tens of kilometers, then we can say much more definitively that this event very likely came from out there. And again, possibly the ex-NATO site in Carp will be useful for this. It's about 80 kilometers away from our main site. And we've been told that we can set up other antennas there if we want to. So we may well end up setting up a couple of antennas with matched pointings to the antennas that are at the Rideau Ferry site. And also potentially use the 14-meter as a verifier. So, you know, 1 week it might spend pointing at the same piece of sky that one of our dishes is pointing at, and then maybe switch over to another one in the following week, something like that. We have a long way to go before we can do that, because we have to restore the ability for that dish to move under its own power. So this is raising ghosts of our Shirley's Bay project, but this dish is in way, way, way better shape. It was built about 10 years later, and it sat under a radome the entire time, so all the mechanicals are in much better shape. So that may be a possibility for us to use it for doing FRB confirmation. Or you might think of it as anti-correlation. If the two sites don't see the same event, then it's almost certainly not coming from out there. But if they do, it's much more likely. So a big question is, how are we funding this? We lost, as I said, we lost funding from Carleton University. But a few weeks ago, I think Kim saw this video, we had a CBC article published about what we're doing. Alistair Steele came out to the site for a couple of hours and took lots of video and interviewed us and all that stuff. And that actually prompted some donations. Some of them were fairly considerable. not enough to allow us to buy any equipment or anything, but it will allow us to continue operations through roughly mid-2023. So we're looking at various communities, including, the RASC and anybody else that wants to contribute. So if you want to make a donation to what we're doing, you can send an email to the address that's listed and make a donation if you like. I have to say in advance, we are not a charity, unfortunately. We are a registered not-for-profit. Well, I don't know if that's a concept. We're a not-for-profit federally incorporated corporation. We may change to a charity at some point, but the governance requirements and paperwork requirements for a charity are substantial, and we simply don't have the people around to be able to take care of that. So we're going to stick with our current corporate structure for now. Our most immediate big ticket need is a power upgrade. We don't have enough power going in there to keep a lot of computers going. And of course, once we have more computers in there, we need air conditioning in the summer, all of that kind of stuff. We're currently maintaining minimum heat inside the trailer because hardly anybody is there most of the time. It's just the computers, so we keep enough heat in there to prevent condensation and to keep the computers, the disk drives from freezing and that sort of stuff. Although most of the disk drives are solid state now, so that's less of an issue. Cooling fans, paradoxically enough, don't like it when air temperatures are really, really low. So, questions?
That was excellent.
Let me unmute
Excellent,
myself.
Yay. And yes, I did see that video, and I ended up sending it out to the rest of the list as well.
Oh, good.
For them to take a look at. And so does the dishes that you have there on the property, are they just regular satellite dishes?
Yeah, they're actually satellite dishes that people were probably using in the 1980s. And there's a local dealer in Smiths Falls who gave me a really good deal on a bunch of them. Like a really, really good deal, like 1/20th of their original, value, more than their scrap value, but way, way, way less than their original selling price. Some of them are in not wonderful shape, but they're adequate. I think our bigger cost was actually, pouring all the concrete and welding up all the steel and all that stuff to build the supports. The dishes themselves were actually not that big an expense. And then of course, we made all the feed systems for them, and we purchased commercial low noise amplifiers, all of that kind of stuff. But the dishes themselves are actually one of the smaller parts of our budget. We did secure 2 years ago now, we secured a 6-meter dish, almost 20-foot dish that was being scrapped by GlobalSat. They're one of these low Earth orbit satellite operators. They have an Earth station near Smiths Falls, and they were doing an upgrade to their antennas. And literally, they called the scrapyard that's like right across the street from them to say, hey, could you come get these dishes? And I had put a bug in the scrapyard's ear years ago about, if you ever get any decent sized dishes, give me a call. So this thing arrived at the scrapyard almost complete. And it would have weighed a couple of tons. It was very, very, very overbuilt. And we couldn't even afford the scrap value for that. But they sold us just the surface without any real backing structure for $200, which we did mostly assemble at the Rito Regional Center just to see how it would go together, which caused us to realize that we were probably going to need several $1,000s worth of mechanical infrastructure just to get it going, just to, get it up off the ground and pointing at things. So it's sitting in pieces out at the site, waiting for, a sunny day, both literally and metaphorically, for us to put it together. And the plan for that is to do a long-term study of deuterium around the North Celestial Pole. That's an entire other project that we called IDEA, which is the International Deuterium Experiment for Amateurs. So everybody points their dishes at the North Celestial Pole, and because that region simply spins through their field of view, nobody has to point actively. And you can measure sort of the average deuterium content of that area of the sky. And if you have enough people doing it, you can get enough signal to noise ratio to say, hey, look, there it is. With a single dish, you can't. Deuterium is about roughly 1/10,000th of the density of regular hydrogen out there. So using a single dish to see it would probably take you decades of integration time. But if you have a whole bunch of people all over North America, for example, all pointed at the North Celestial Pole, they can just let the thing run forever, and you just integrate over very long periods of time until you get a decent signal. So that's what the big dish is for. I don't know if we're going to get it in place in the next couple of years, to be honest.
So would you be able to take these satellite dishes, only because we have a couple of them sitting in our back 40, and be able to just have it drift scan and look at the celestial pole?
Yeah, I mean, yes, absolutely. How
Yeah.
big are you? How big are the dishes?
3 meter.
Yeah. Okay. Yeah. Yep. That's big enough to contribute to the overall integration.
Yeah.
It's yeah, just pointed at the NCP, and with a 3 meter dish at 327 megahertz, it's barely big enough, but it'll work. And your beam width will probably be about 25 degrees, something like that, which is fairly big and sloppy, which in one sense is great because it means your pointing accuracy doesn't need to be super wonderful. Talk to me offline and
Sure.
and yeah.
No problem. We got to do something with these dishes. Okay. Does anybody else have any questions for Marcus? You can, oh, Kevin does.
I am shocked, I tell you, to find that there's been gambling going on at this establishment. No, wait a minute. Shocked that there is a new astronomical phenomena that has just been discovered, observed, recorded in the last 15 years. That is also something that a backyard astronomer can contribute to. And that's fast radio bursts. I didn't even think for a moment that we could compete or even get in the game with Chime and others. Have you thought, maybe, are there any other possibilities that we have overlooked over the years for something new to look at that we just haven't?
I mean, the FRB observation thing is kind of on the edge for the size of dishes that even we're deploying. The only saving grace we have is that we've got a number of them. So if you have like a bouquet, if you will, of dishes, you can. I mean, you can't compete with Chime. Chime is an amazing instrument for doing this, but there will be, I posit, there will be a population of FRBs that are bright enough for the amateur to observe once in a while. And the question is, are you in the right place at the right time? The STARE-2 project, and I didn't really emphasize this enough in the talk, the STARE-2 project success was the thing that drove us to think about doing this as well, but with a different architecture, because they have essentially no antenna, really. I mean, it's just a naked feed horn with a good ground screen. And they were able to detect after a year and a half this magnetar outburst. That suggests to me that there is a population somewhere between that very bright magnetar outburst and the kind of much weaker bursts that Chime is able to detect. So we're not going to know for probably a year whether there is any such population. I suspect there is, because the universe is just like that. And the other thing to note, I mean, Chime's field of view is extremely narrow. So they also have to be in the right place at the right time, which means that there can be these things going off all over the sky all the time, and nobody's observing them, which means that, yes, amateurs with a bit of technical know-how and maybe a bit of a budget could throw a couple of dishes up in their backyard, you know, one pointed north, one pointed south, and just let the stuff run, you know, for weeks and weeks and weeks and weeks at a time, and you just ignore it. We are going to have to solve the sort of wheat from the chaff problem, obviously. But yes, I believe this is something that amateurs can contribute to. The other one where amateurs can contribute is this whole idea project. There is a memo on our website that describes the project. Knowledge about the distribution and sort of, you know, minimum quantity or minimum density of deuterium out there in the universe is actually pretty thin on the ground. Because to observe it at all, you need to dedicate fairly large amounts of time to it and fairly large amounts of aperture, because it's just so incredibly weak. You know, like I said, about 1/10,000th to about 1/50,000th of the density of hydrogen, of neutral hydrogen. So it's something that requires very long dedicated observing periods, and big observatories aren't going to do that. Not the traditional ones with movable dishes and all of that stuff. They're just not going to do it. The sort of scientific return for them is not good enough to justify it. But again, a flotilla of amateurs doing that, just that, you know, and to, let's say after a year or two, be able to definitively say, yes, we saw this much deuterium in the region around the North Celestial Pole. That would be fantastic. That would be a paper in you know, one of the astronomical journals, and it would, you know, it would have many names on it, because there would be lots and lots of contributors to the final integration, if you will.
Okay, that's excellent, Marcus. Thank you for presenting this evening.
Oh, you're most welcome.
And yes, I will contact you offline to see what we might be able to do with our dishes that are sitting here. Okay. Next up, John Hurley, update from National.
Hello, everyone. This past weekend, the National Council had a meeting, and one of the things that has come up is our board of directors will be having their very first in-person meeting later this month, and it's going to be over a day and a half. So that should be some changes coming down. There's been a few things that are supposed to be coming to the center, but they've been slow in coming. Maybe they've been waiting to meet in person and hash some details out. As far as the shipping and handling and issues for handbooks and calendars and stuff, they had to reorder some calendars, so there's more available. So if anybody's interested in another calendar, they can order that now. They also believe they have everything caught up for back orders for handbooks, calendars, and the latest issue of Sky News is in the mail, and it seems to be coming out over a very extended period of time to some people. I have yet to get my copy, but they're working on it. And if anybody has any issues with their membership, please contact National Office, and they'll be dealing with things on a one-on-one basis. There is also, where is my note here? Yeah, so any more issues? They annual statements, the GA is coming up at the end of June. Please keep an eye on the website for registration information. It will be a totally virtual GA again this year, so minimal cost. Apparently they have a really good guest speaker this year, but they were awaiting confirmations before they release any names. There's also been a very generous donation to the Society at the end of our fiscal year, just of $1 million. Somebody remembered the Society in their will. So that will be showing up on the books, and there's a few $100,000 more to come in this fiscal year from that bequest. And at the moment, I don't know if there's I don't think they've fully got plans worked out what to do with that money. That may be part of what the board meeting in a couple of weeks is up to. But that is a very generous donation. And if any of our members are looking how to get rid of the money when they pass away, please remember the center. We may want to help with some radio observing sites or telescope sites. If I could try this, let's just screen share for a second. And is that coming through? This is the office staff at National Office. I was also asked to remind everybody, and this has not been a big problem, but over this past winter with all the problems that have been going on at the office, there's a bunch of new faces. And we're supposed to remind all our members that please be polite if you're having contact with National Office. They're trying to work through problems also. They've just worked into a new site this Christmas, so they're still unpacking and getting things organized. And a lot of the staff is still working remotely. They come in for like one day a week or one afternoon, and it's very still chaotic, but they're working their way through it, and hopefully things settle down very shortly. This is the building National Office is in. We have the entire second floor. We have a few shots of the inside at the moment. As you can see, they have lots of space and lots of unpacking to do. Need to get some filing systems going and unpack some telescopes for a telescope museum that will be set up there. And they have a whole lot of programming coming this year. The NOVA, the New Observers to Visual Astronomy program, will be starting up. We participated in some of this a few years ago as a center for the public. So if any of us want to participate, there will be some introductions at the GA. They'll be launching the new program in the fall, and the new course offerings can be found at the National's website. They're also looking for people, if anybody wants to do robotic telescopes in the classrooms. They've been doing planetary occultations with some science classes from across the country. So if anybody knows any classrooms or teachers that might be interested, please let them know that the society will be more than happy to help with this. We have basic and advanced programs, virtual field trips, and it sounds like a very interesting program. Let's see here. And they're also selling packages of data to members. If anybody's interested in doing picture processing or data mining, they can get access to the data from the remote telescope for a small fee for a yearly subscription, or become part of the science programs and teams and stuff. The National Office is also offering a software program for Stellarium, if anybody's interested. And these programs come in basically beginner and more advanced users, and they're free to RASC members. Then you can find information for that again at the RASC/Astronomy Software Training. And Stellarium is a free download if anybody is interested. The Education and Public Outreach Committee is also keeping themselves busy, serving certificates, helping some high school astronomy clubs, creation stations, and moon themes this year. The RASC is also involved with the Artemis launch program with the Canadian Space Agency and helping to promote the exploration in science. RASC also does do some online YouTube and training webinars. So please check the website regularly, check the email list. And the ones that I've attended so far have all been pretty interesting and informative. And here's a little more information on the Artemis launch and our tie-in with them. We're hoping to have some star parties with the focus on the moon happening across Canada in April and May. Haven't heard too much on that at the moment. And here we go. They're looking to get our with all the problems with the shipping that happened. The shipping company has been given their notice, and we've taken it in-house for now. And we are looking to get a new shipping company to help provide national office for its needs. And they will be going through a much more rigorous interview process for all this, because the last company was wonderful on paper, but when it came to shipping, we found out, partially to COVID and other reasons, skids of handbooks were left at the back of the shipping warehouse for months, and we were told they were shipped out and lost in the system somewhere. So they're looking for a new company. And this came from our National Executive Director, Phil Groff. He prepared these slides. And let's see here. There's the I'm just trying to get the stop share here. There we go. All right. And we have the next council meeting will be on June 5th. The GA is coming up in the end of June. So hopefully everybody can attend part of that, because it sounds like it might be a very interesting time. And hopefully this by next year, we will be starting having GAs in person again. They might be a combined GA, but we are looking into separating the annual general meeting going on at a separate time and place from the GA. Keep the business and the pleasure a little more separate. That may help ease some of the organizing burden, but that's what is in the works now. And at the moment, we don't have any centers volunteering to host the GA for 2023. But hopefully somebody will step up and help lead us back into in-person meetings at the national level. And that's all for now. If anybody has any questions or concerns, please let me know, and we'll see what we can do to help out.
Okay. Thank you, John. Lots of information and lots of things happening at the national office, and we'll filter down to the center. Next up, we have Hank Bartlett, Hank Sunspot.
Good evening, everyone.
Hello, Hank.
Okay, yes, hello, share here. Looking for it, there we go. I think that's it. Share. A little bigger. And do we have full screen? I hope so.
We do. Go ahead.
All right. That's what I'm waiting for. Okay. Good evening, everyone, and welcome to Hank Sunspot, February 9th to March 8th. That's our meeting month. I have cut it a day shorter so that I don't have to do anything on the last day, which would be today. It's a rather non-technical review of solar activity during the past meeting month, and with images by myself and other members, which is usually just myself and Kim. I would really like to get some images from some of you others. Get out and put a camera on and take a picture, even with your cell phone. As you can see, I had a guest observer this month, and he said that basically our sun is quite like one of the three around his planet. They have summer, spring, summer, fall, all year round. Beautiful place. But so here we go. It has been a weird month. Things have been going so well of late. And then it seems that during February, late January, early February, the scene went all to hell. It went bad. It went really bad, especially in hydrogen alpha. And things have not been that good for imaging. So between cloudy weather, bad scene, and events that have happened on the other side or during dark, it has been a rather boring month. So I've kind of lost a bit of touch with things, but I cobbled this up for us to just have a little look at here. And you can see here the first excitement of the meeting month was the February 12th M1.4 flare originating from AR 2944, followed less than 9 hours by a C9.2 and a C8. And you can see on the right-hand side here, the flare bursting off the side, the western limb of the sun. And these kind of events are actually quite exciting, because when there's a flare just in front of you, right in the center of the sun or on the main face, all you see is a bright spot like this one in the first image from the left, this bright white line, and not much else. Sometimes you see a filament break away and go off, and that's really exciting. But when you see it from the edge, you see what actually goes on. And there's been a few dandies this month, but they were not particularly in best time or place for us. And you can see here on the left-hand side, the M1.4, and then followed by the C9, 2, and the C8 in the graph here, which I currently get from a station in Russia. So I don't know when that's actually going to disappear or stay or what. We could lose it at any time. But it's the one I prefer out of the ones that I've seen. Now, for aurora lovers, hopes were dashed this past month. This is the 12th, 13th on the left, the 15th, 16th on the. These were the ones that I said happened out of sight, kind of. The one on the left, the bright one there, is the M1.4. One of those. I'm not sure which one. I did not go back to timing it. I believe it's this first one right here now. And these happened in bad time for our time zone. Then on the right, this one came from around behind the sun. And it was absolutely stupendous. If this had happened when it was on the face of the sun and pointing at us, we might not even be having this Zoom meeting right now, because maybe too many satellites could have been knocked out. Amazing. And here is an image of the actual event from the ESA, European Space. I can't remember what it is, the A. But anyway, it's from their spacecraft. And this reached out 1.5 kilometers to the northeast of the sun. And as my wife said today, where I brighten it on the left-hand side here, this looks like a crab right here. Really cool. And we get excited about a flare that goes as far as this yellow part down here on the left-hand side. Never mind all this far out into space. Absolutely amazing. Now, this was done by the former sunspot AR2936, was responsible for it. And when it came around again on the 20th, it was renamed as 2954 with an accompanying spot following a couple of days later, or a day or so, 2955. I don't know why they change with the technology we have nowadays to really know that it's the same sunspot, why they change and give it a different number. I don't dig that deep into the technology of it all, but I would think that when I've seen sunspots go around 3 times, 4 times, they would keep the same number and it doesn't falsify the actual count of sunspots that way. But anyway, this pair came around, and by the 22nd, they were both around, and they obviously had exhausted their combined solar fuel, because after that outburst, there only gave us another 2 C flares, and that was it. But by gosh, I'd sure like to have seen this. Now, on March 2nd, we've jumped a long way here into the month of March because, as I said, in February, the observing was terrible for the most part, imaging especially. Even the observing, you couldn't get a good grip on any sunspots, any prominences that well. And the sky cleared, and yay, we loved it, resulting in these 2 images here. And AR 2955-54 has now been replaced by the alpha beta tug of war between 2957 and 61, which they kept switching back and forth, alpha beta. And we'd like it just to keep climbing instead. But anyway, it hasn't produced a heck of a lot of flares, and not anything that has been consequential to the Earth as far as aurora or anything like that. We were fooled when the tiny 2958 released an M2.02 out of nowhere, and that was on the 2nd, and it's right here on the right-hand side. I have put in a black and white or grayscale image of the flare on top of my image to show it, because I did not catch it. It was at 1738, which is only what 1338 our time, but I just totally missed it, unfortunately. But there has been good activity going on and better skies, but just not the way we'd like to see it. Here's a couple of images from Kim. It was, as she quoted on her email, it was 13 degrees Celsius and a slight breeze, clear blue sky, beautiful day. When I started solar observing, an hour later, the clouds moved in. Yes, I remember them because I was out too, and the clouds did move in. Enough to ruin the images, and the wind picked up, and the wind picked up very quickly. That was the day that we were supposed to have the 100-kilometer winds that never materialized, the 80 to 90-kilometer winds that never materialized. So enclosed in one image in white light, colorized, and 2 HA images, 1 prominences and 1 surface detail from Kim. And these are very nice images catching the sunspots in both, as she said, white light and over to the right in H alpha. And then just moving something in here, the prominences around the edge. Prominences have been pretty good of late, which is always something that one of the joys of H alpha imaging or observing is that even when the sun looks bland sometimes, or the spots are beautiful and big but inactive, you can get some really nice prominences. Now, here's one that was done by a fellow in Germany that I pulled offline. And this is a beautiful vortex that would swallow the Earth, swirling faster than 50,000 kilometers or 50,000 miles per hour. And it's absolutely amazing. It, as Di commented earlier to me this afternoon when I showed it to her, it looks like a ghost of some kind with a face in the middle with a kind of a hooded ghost. I would have loved to have been able to sit and watch this for 25 minutes. When you can see real-time movement in a prominence, which I've only seen once back in 2012, it was absolutely stunning to see it growing and moving any large amount. So kudos to this fella for that. And I had his name there earlier, but it seems to have disappeared. I don't know where that went to. But
We see it, Hank. Alexander.
Oh, do you see it?
Golubchik. Yep.
Yeah, I don't have that here in my. Oh yeah, there it is. Okay, sorry. Yep, I had the share bar in the way. Yeah, Alexander Golubchik and Darmstadt, Germany, and this is a real coup to get an image like this. It's absolutely fantastic. So everybody try and work for that. You know, get yourself an H alpha scope and shoot at these things. And now 220308, my last observation of the meeting month was these two images, three images actually, and scene was really good, well defined, and you can see here that I have put an inset of the sunspot AR 2960 as well as the original image, and to see sunspots like this is absolutely stunning, and you can do that with just Bader film. It doesn't cost you more than a few cents or a couple of dollars to put a Bader film on your scope and go out and look and see something like this. And if you have a high F scope with lots of power, you can see absolutely amazing detail on these. So I urge all of you to just, you know, go ahead and buy a little Bader film, slap it on the front, and take a look at this. Now you can see on the right hand side the H alpha image. In the upper left, this spot 2965 is coming in kind of hot. So I hope today, it was cloudy today, so I couldn't see anything, but I hope that it is bringing some really good spot and activity with it. In the images that I saw from the SDO, there is a couple or three big spots, and it's looking really good. So hopefully we're going to, in the next few days, see some better activity. And for the summary of the month, this past month, we've had, oh, I forgot to finish that. What did I say, 65? 65, I missed finishing that, sorry. So there has been 23 active regions, not 20. And then X flares, none. M flares, the same as last month. But C flares have dropped to 64 from 148 for a total of 68 flares altogether. Odd. I really didn't expect that to happen. I expected it to stay up over the 100 for sure. A little bit of a downfall is one thing, but this is way down, less than half. And I had 14 observing sessions in the past month, and I'm all right with that, but not totally happy. So that's it. And hope you saw something you liked.
Thank you, Hank. And thank you for putting my pictures in there.
Absolutely. I wish more people would send and you would send more, because I get tired of just putting my own pictures in. It's not the Hank show.
That's okay. We got to wait for better weather. Yes, it was supposed to be sunny today. That didn't happen. So anyway, thank you again, Hank. And will we have anything from next month?
Oh, you're talking to me still?
Yep.
We'll see. I don't know.
Depends on if you can hook up or not.
Yeah, hook up or not. And and how busy we are down in
Yeah.
Costa Rica. So
Well, have a vacation.
I'll try and send something along, or try and at least watch some of the meeting.
Okay, that'd
All
be
right.
great.
You're welcome.
All righty.
Bye.
Bye. Okay, next up we have Rick Wagner, who's going to do What's Up in the March Sky 2022. Take it away, Rick.
Well, good evening, everybody. See if we can get it shared here. Can everybody see that? Take a little while to come on, I suppose.
It's slow to come, and this is Kevin just reminding everybody that Rick has a slow internet connection, and that is the reason for the audio audio anomalies. That's it.
Am I getting audio anomalies too? One thing I'd like to try sometime is whether the size of the window that I'm sharing makes a difference on the speed. But anyway, so our sky for the month and astronomy events for the coming month or so. On Friday afternoon, Queen's University Astronomy Department has Kate Skolberg from Duke University talking about what stubs and sparkles in vast vats of liquid will tell us about exploding stars. So anybody who's familiar with Queen's will know that she's talking about neutrinos in various types of liquid, cleaning fluid and xenon and goodness knows what else. The Queen's University Observatory, Nick and Connor have added 2 new fast radio burst podcasts. This is their little interview/lecture series that they have on the home site of the observatory. Cupid's Arrow Hits a Black Hole, featuring Charles Woodford, who's a relatively new guy at the McDonald Institute. And then Living Universe number 2, The Great Filters. And I haven't had a chance to listen to that one yet. BAA events. I noticed that as the restrictions are lowering in the UK, their number of online events seem to be decreasing. However, on the 16th of March, they don't actually specify a time, but I'm assuming it's the regular 1400 in the afternoon for us. A history of mirror silvering for telescope meeting group. AVSO webinars, 26th of March, Dr. Emily Levesque from University of Washington was going to talk about the last stargazers. It comes from her book on the subject. Basically stories, interesting stories, amusing anecdotes from her time as a professional astronomer, visiting some of the biggest observatories in the world and so forth. 5th of March, this Saturday, I seem to have got these out of order. The Emily Levesque talk is for members of the AVSO only, but on Saturday, no, I've got the date wrong there. Anyway, the first Saturday of the month, that probably should be 5th of April, they have a how-to hour, and they don't yet have a speaker and topic designated for that yet. Up in the sky, hours of darkness this month. You can see we continue to lose more and more of our night. And by even before the end of this month, we are down to less than 12 hours of darkness and twilight. And by the end of the month, down to actually 8 hours of astronomical darkness. And of course, starting fairly shortly, there's a big 1 hour jump in all these sunset, sunrise times and everything that we all decry. For the solar observers, mid-month, later in the month, the sun finally gets above 45 degrees elevation in the south at noon. So seeing should get better and better. Sky events for March. First quarter moon is tomorrow. 13th of March, daylight saving time begins at 2 o'clock in the morning. 18th of March, we have a full moon. Let's see, 20th of March, Venus will be at greatest elongation east. So that's its furthest distance east of the sun in the southeastern dawn sky. And also on the 20th, we have the vernal equinox at 11:33 Eastern Daylight Time. That's, of course, when spring begins in the northern hemisphere. The snow is all going to melt, the sun will come out, and we're going to start losing even more of our night times. Starting the 22nd of March and going for a week and a half or so, you can watch for the zodiacal light in the evening sky after sunset during the darker parts of twilight. 25th of March, last quarter moon. 26th of March, Earth hour from 8:30 to 9:30 in the evening. Everybody turns off all their lights, their electrical items, and goes out and enjoys the clear sky. Don't do like I do. Plug your computers all in, get them all charged up, and then you can run them off battery through our Earth hour. 28th of March in the morning, the moon, Venus, Saturn, and Mars form a nice compact group in the southeast before sunrise. 29th of March, Venus will be 2 degrees north of Saturn. And also on the 29th, Algol will be at minimum at about 9 o'clock in the evening. Then extending into April, coming up to our next meeting, 1st of April, April Fool's Day is a new moon. Also on the 1st of April, an 18-hour-old crescent moon, very low in the west after sunset. This is not a favorable apparition, but it's probably worth giving it a try. 4th of April, Mars will be 0.3 degrees south of Saturn in the dawn sky. And on the 9th of April, we have first quarter moon. So a few pictures of what's going on. Venus at greatest elongation east on March the 20th. You can see the red line on this picture is the ecliptic. So that's the line that the planets, the sun and the moon, roughly follow as they go around the sky. And you can see that because this is the dawn sky in the spring, the ecliptic is very low, very close to the horizon, the green horizon line across the middle of the chart. So as a result, things are not very high above the horizon when the sun is still below the horizon. And as this is the 20th, you'll notice that the sun on the ecliptic is also on the equator, and that's what makes this the vernal equinox. And in comparison, here's the view the next evening, looking to the west, and you can see the red line of the ecliptic is very high, standing almost straight up from the western horizon after sunset. So the planets tend to be much higher above the horizon after sunset in the evening sky in the spring. And the red line of the ecliptic is where you'll see the zodiacal light. It'll be a big triangle of faint glow extending from where the sun has set up and to the left along the ecliptic. Planetary grouping on the morning of the 28th, you can see this is, I think, a day before the tidiest grouping of planets, but it also has a crescent moon in. Venus, Saturn, and Mars nice and close together with the crescent moon down below them. This is at the beginning of civil twilight, so the sky is already going to be quite bright. Venus will be very easy to see at this point. The moon probably quite easy, but you may need binoculars to pull out Saturn and Mars. And then the very young moon in the evening on the 1st, but you can see that the moon is actually way south of the ecliptic. and still quite close to the sun. So this is this view is when the sun is about 3 degrees below the horizon, and the moon is about 2.5 degrees above the horizon. So it's going to be very low. You're going to need a very low western horizon if you want to see this. Asteroid activity on the 12th of April, number 8, Flora, will be at opposition at mag 9.7, easily visible in a small telescope. And then there are 4 possible asteroid occultations this month, some of which are quite interesting. On the 12th of March, Rote will occult a 9th magnitude star. So this is nice and bright, easily visible in a small telescope. The asteroid itself is at 15.6 magnitude, so there's about a 6.5 magnitude drop in the brightness of the combined objects if it goes into, if we get to see the occultation. The occultation can last a maximum of 6.8 seconds. So here's a map of sort of Kingston and north. The green line through the center is the center line of the predicted path. The blue lines are the edges of the predicted path, and the red lines are the ones deviation. So sort of a plus or minus 67% likelihood that it'll be within the red lines. So you can see even for Kingston, there's a fairly good chance of seeing it, but certainly many of the members who are north of Kingston have a good chance. That'll be a really exciting one to watch, and it'll be fairly high in the sky as well. Number 68, Leto, is going to occult a 12.0 magnitude star. Now, the asteroid itself is only 12.4 magnitude, so the drop in magnitude of the combined objects is only 0.9, but it's a 122 kilometer asteroid, and the maximum possible duration is up to 32 seconds. And you can see Kingston in this case is within the predicted path. So again, this is an object that's going to be fairly high above the sky, 12th magnitude. You probably want a 6 or 8 inch telescope to be able to see it well enough to be able to spot a 0.9 magnitude drop. 356 Liguria. This one happens, you can see from the view of the Earth from the asteroid that we're much closer to the limb, so it'll be further down in the south. Also 12.5 magnitude star, so fairly faint, but a 16th magnitude asteroid, maximum duration 3.5 seconds. So 4.1 magnitude drop in brightness. And this one, you can see the center line is up near Charlotte Lake, up near the Hurley's place. And Kingston again, in fact, all of southeastern Ontario, well within the path, the predicted path. This is fairly good-sized asteroid, 44 kilometers. And finally, 153 Hilda, happens to be my grandmother's name. On the 5th of April, a 10.2 magnitude star, nice and bright, 12.9 magnitude asteroid, and 2.8 magnitude drop in brightness for a maximum of 13.5 seconds. I think this one is particularly interested, A, because it's a nice bright star, so it will be easily visible, easy to find, but also during the actual occultation, you'll be able to see the asteroid at magnitude 12.9. So it's unusual in that you'll be able to see the asteroid as it's covering the star. It'll be quite different. And again, a nice wide path, Kingston and area. I think all of our members here are within the predicted path for this one. That's all I have. if anybody has any questions.
Thank you, Rick.
Thanks, Rick.
That was great. Everybody get out there and do some observing. Those occultations certainly sound interesting.
Yeah,
Okay.
I'm gonna definitely try for some of those.
Yeah. Now, do you actually have a time inserter for the timings?
No. What I've been using is a CMOS like planetary camera,
Mhm.
and so it, I think, keeps a good track of the time. So, and the thing is that even if you're not timing these events, they're still really interesting to watch.
Yep, definitely. That's for sure. Okay, thanks, Rick. That'll be, I'm pretty sure, up on the website soon. And I'm sure Elena will put it in her notes and we'll get it out to the list as soon as possible if you didn't take notes, and you'll be able to watch it on YouTube later anyway. So carrying on, we have a science rendezvous that's coming up in May of 2022. It's going to be a month-long event holding various virtual and in-person events. We will be working with Queen's University and RMC doing solar observing and solar layout. So we're just in the planning stages now of what we need. And we should be having another meeting soon. So far, we have a couple of members that are going to be participating, but more is always welcome. So our next meeting will be April 13th at 7 p.m. Our guest speaker will be Peter Pecora from Sudbury, and he's going to be talking to us on the fun of making large aperture ultra-fast Newtonians. So he was recommended by our speaker in December, which was Alan Ward, who also makes big mirrors. So this will be more into line into telescope making. Every Wednesday, except the second Wednesday, which is our meeting night, we have the social Zoom time, which Susan looks after and sends out the link every week. And that's on our chat list. You can check out our website as well. It will be on there. We are on Facebook into the RASC-Kingston Center group. Twitter at Astro-Kingston. Check us out on YouTube. We have our meeting, past meetings there, as well as other astronomical events we've done. And at this time, this concludes the official ending of our meeting. So I'd like to thank you, those who are on YouTube, for sticking around and being with us tonight. And once we